Gentlemen, so we're going to draw, let me just get the picture up quickly, a tilted solid. So it is square, pyramid. Alright, so what's given to us here is an auxiliary, so the blue is the auxiliary, and that auxiliary has aligned itself with the tilted front view. Okay, alright, so that's what you would be possibly given in an assessment. Alright, so you need to know though, and you need to be able to understand the language, that the auxiliary is aligned with the top view and shares a common point of tilt, if it might say something like that. Okay, right, so the first thing we're going to do is draw the square, the top view, or the auxiliary top view, which is that what we see in the blue. So if we're given the length of one side of a square, there's two things we can do. We can either use our 45-degree set squares, or we can use a compass. We can use a compass, and we can draw a diameter out of 40 using then obviously a radius of 20. Okay, so that's what I will do. I use my compass because I think my compass gives always the most accurate reading. So the first thing I will do here though is I'm going to set up on my page. If we're going to do, let's for this argument's sake, let's say we're going to do the left view. Okay, we're going to do the top view, we're going to do the front view, and we're going to do the left view. So what I'll do is, we know then if we're going to have front in the top, and then the left will be on the right because it's first angle orthographic projection. So what I'm going to do is I'm going to start drawing to the left hand side of my page, and I'm just going to make a little come down to the bottom here for the top view, and I'm just going to make a center marking, just in some light detail. It looks dark on my page, but it's not, it's quite light. And let me actually use a different color as well. So I'm just using a light green there. Good. I'm going to just make sure I've got my compass ready to go. Alright, so I've got my little center markings in place here. What I'm going to do is I'm going to open my compass to 20 because the length of one side is 40. So we're doing what we call a circumscribed square. So the square is constructed on the circumference, around the circumference of the circle. So I'm going to take my compass, I'm going to measure, what did we say it was 40 here, guys? Yes. 40. So I'm going to take my compass, open to 20 because my compass works with a radius, and then I'm just going to scribe a circle from that center point all the way around. Okay, there it is. So that is going to be the circle on which I circumscribe this top view. Let me come zoom in a little bit, yeah? So there it is, and remember we're referring to the question here. There it is. So we're doing a tilted top view, a tilted front view, and a tilted left side view in this drawing. Okay, so now that we've got that circle in, I'm going to use a different color to designate my square, but we're going to run 45. So if we look at the nature of that, so we come back to this regular square. Okay, so it's a right regular square of 40. So those are going to be at 45 degrees off the axis. Okay. So we go back to that, back to our drawing boards, and all I'm going to do is make sure, but we want tangents here. So a tangent is essentially a 45-degree line that touches the circumference. So that's, you can see there, that's the positioning, that's to touch. So we want to draw a line that touches the tangent, it's tangential, to the circle, all right, and we want to intersect the corresponding, if you like, axis. Okay, does that make sense? I'm going to do that from all sides. I'm going to run a tangent down the bottom here while my ruler's in the right position. Then I'm going to flip around, and I'm going to do the same thing here. So there's a nice tangent there, and you'll see they should meet on the axis nicely there. That's when you know you're really on the money in terms of accuracy, when you meet on that axis like that perfectly. There we go. Okay, so that's my auxiliary. Now that I've got my axis in, I don't actually need to go draw the tilted edges to the point, because those will act as that. Does it make sense? Okay, right. What is the next step from here? So we've got the auxiliary in now. Okay, I'm going to suggest this before we go. Those of you who don't back your ability to track your eye without annotating letters or numbers, that's perfect. Do that. But I'm going to always do this. When I say I'm always going to do this, depending on the drawing, I'm going to, for example, I'm going to call that 1, I'm going to call that 2, I'm going to call that 3, and I'm going to call that 4. Okay, so that's the points on the base edge. And then obviously at the top here, what have I got? I'm going to call it A for the apex. So where all points, we can call it apex, a vertex, whatever. So, right. We then need to go and how do we build this up? Because we're going to go draw the front view now with a tilt at 30 degrees. You're going to go 10 to the margin, from a margin to the axis 10, and then another 10 to a margin. Okay, so what do we mean by that? I'm going to use my blue now for this, just a different color. Okay, so there's a margin. We're going to go 10 up for an axis, and then another 10 to the margin. So that'll be 10 up to the actual axis itself, and then another 10 to a margin. And I can just draw this in nice and light detail, and I can extend everything later. I'll extend my margins a little bit later. The most important thing here is to just get, right, there we go. So I now pull these points, okay? So I'm going to pull these points up. I'm going to pull these up to the margin, so there's 2 to the margin, and I'm just going to annotate that just now. 1 and 3 are obviously along that line there, and then 4 I'm going to pull up to the margin over there. Okay, so what we have here then is 4 on the margin over there. There's 1 and 3 as well as A, and then 2 on the margin there. So we've pulled them up. Remember, this is my axis here. In the middle is my axis. Okay, you guys with me? Yeah. Okay, cool. And I'm just going to give us some space at the top here so that we can start to draw the top view in. Okay, there we go. All right. Right, so with the tilt, if we go look at the tilt, so let's go back to the question. The tilt is at 30 degrees, and we know the tilt's on which point? Number? 4. Let's go back. Number 2. So if we go back here, it tilts on number 2. So we're going to draw a line out at how many degrees? 30 degrees from point 2, because that's the point in which it shares its tilt with the auxiliary. So I'm going to take my construction line from 2 at 30 degrees, just draw a line out that long. Right, good. So the base will share that line, the actual base, the outlines later. Good. All right, to get all our points along our base edges or points correctly along the tilted plane there, we need to use our compass. And we're going to imagine is that we were manually tilting the object. So obviously the point on which it tilts is 2. So we're going to go from 2, right, to 1, 3, and A, which are on the same plane. And we're going to swing them around, and we're going to mark their positioning on that 30-degree tilt. And I'm going to go all the way across to 4 as well. I'm doing this slowly. See, I've lost my point on 2 there. Stay there. Okay. There it is. There's 4. Swing it around, and that's my little mark there. Okay, so again, I'm just going to annotate again. That's going to be 1, 3, and A, and that's going to be 4 there. Okay. Good. I might be over annotating, but it's just for the sake of the demonstration. Okay, so then if we go back here, so we have a look at that. What's the total height? Now, interesting, a lot of people do this incorrectly sometimes. They measure 70 on a random angle, and you know what I mean? So they might do this at, I don't know, whatever degrees, 30 degrees. All right, and then it looks sloppy, it looks like jelly, it looks like it's falling over. What we want to do here is we want to do 70 perpendicular up the middle. All right. And what would we use in? If we had 30 degrees going to the left, we're going to have 60 degrees going to the right. That 60 degrees to the right will then give us the perpendicular. Okay, so we go back to there, and we're going to add our 60 degree of that. And we're going to get our height up along the middle there. Okay, cool. Then I can go measure 60 degrees. 70 millimeters, excuse me. 70 mils. Okay, to the apex or the vertex at the top, whatever you want to name it. Okay, so the top of the pyramid. So then I can just swing those lines down to go meet their corresponding points on the base. So one thing that's kind of easier than a pyramid, a prism, is that you don't have another 6 points to find. You just work towards 1. Okay, it's just a little bit more difficult when we conceptualize. Right, so I can go create my outlines here, my A-lines. Get some A-lines in, some outlines. Okay, your 0.5 or 0.7 HB, depending on what you use for constructions. Okay. If you find that your drawing is getting a little bit messy, you can add a little bit of baby powder, which I'm going to do now quickly. Just a touch of baby powder, just rub that in to collect all the HB particles. Right. So in the next part of the drawing, we're going to draw the top view, and what we need to do here now is to take 1, 2, 3, and 4, as well as the top, and we need to pull them across. All right, project them across in the direction of tilt. So we can see that we've tilted towards the right of the page, so we're going to send these projections to the right of the page. Okay, we send them to the right, and then this is going to be now a matter of orthographic projection. Okay, so 4 and 2 will tilt along that projection. However, 2 stays fixed because 2 is the point on which we tilt. So obviously that won't move. Okay, so 1, 4, and 3 are going to find new positions on these projected lines. Well, where on those projected lines do we find their new positionings? We come up here to where they are on the front view, and we're going to pull those down. So if I take 4, I'm going to bring 4 down, right, and I'm going to intersect its projection to the right. And I'm going to do the same with 1 and 3. So I pull that down, it intersects 1 there, continue it down, intersects 3 there. You'll see those are on the same plane. And then 2 stays where it is. Then along here, we've got the projection for the apex or the top. And we're going to go to the top of the pyramid over there, or A, we call it A. And I'm going to bring that straight down as well. And there, that's where it meets there. So A's new point is going to be over there. Okay. Right. So now we've got to decide what we see and what we don't see. Right. This is where your conceptualization comes in. But if you were looking from the top view, so if we were looking down there, the closest seen to us is going to be A2, 4. So we can be guaranteed that A to 4 we will see. I'm going to draw this now in outline. So A to 4 we will definitely see. Right. And then around the sides here, we will see 1 to A and 3 to A. If you can, you just got to really try and imagine yourself looking down on this. Unfortunately, I don't have a SketchUp model for us on this one today because it's kind of spur of the moment. So 1 to A is going to be seen, and so will 3 to A be seen. Okay. Then the base edges, then obviously from 1 to A and 1 to 4 and 4 to 3 will also be seen. So in other words, those base edges will be seen as well. Now, you will see that if we had to go from from 1 to 2, it will be behind the surface here of 1A and 4. And therefore 2 here, 3 to 2 will be behind A, 3 and 4, and therefore it's going to be in hidden detail. So when I go from 1's new point to the tilt on 2, I'm going to be working with hidden detail. And I'm going to do the same thing from 3 to 2. For some people this is a little bit harder to figure out, but that's what we're looking at there. Okay. We would also join 2 to A, but that overlaps with 4 to A. Right. Once we've done that, the next part of it is to move towards the left view, but we need to make sure we've got margins set up as well as our 45-degree perpendicular deflector. Okay. So I'm going to then measure. That will obviously be the axis will be on the A. We'll find our axis on A, so we're going to go A there, and then we're going to go across 10 and 10, 10 and 10, and then we can get those. So there we go. So that's margin, that's axis, and that's margin. Okay. All right. You can actually start to label these margins the axis in a little bit, but the next thing we need to do is then get our 45 degrees. So where the axis intersects. So if I just put a little marker here there, and I put a little marker there. There's our axis, and you can see where the axis intersects over there. We want to have a 45-degree line that's going to help us to deflect as perpendicular positioning up into the left view. And that's what orthographic means, parallel and perpendicular. So we need a drawing technique that helps us to do that. And that's what this is. Right, so I'm going to pull that margin across. Pull that margin across a little bit. And I'll pull the axis across as well, just... Okay, you'll see it meets nicely on that point. That's when you know that margin meeting on that 45, you're in a good place. Right, so I'm going to pull then. 1 obviously is on the margin, so 1 is going to be there. Right, then I'm going to pull 4, 2, and A across onto our little 40 perpendicular deflector here. So I'm going to pull that across there, and then I'm going to pull 3 across as well. Extend those lines, the same ones so along the same plane as we worked earlier. There's the points. So here again, we've got now 2, 4, and A, and over here we've got 3. So from there, what do? We pull those straight up into the left view quadrant. Remember, we're doing the left view now, so that was the top. Now we're moving into the left view, right? And the left view we draw on the right because it's first angle orthographic projection. You can go look that up online. If you're struggling to see it, they give you nice images of why that is. Okay, so, oops, I didn't project that properly. Project that up as well. So 1 I'm not projecting because it's on the margin. I don't need to project that. But let's follow with the annotations again. So that's going to be 1. That's going to be 2, 4, and A. And that's going to be 3. Okay. Right, so those are the positionings there. Now I'll just project across and I'll position according to my projections. So we projected to the right and up, okay, our widths, and now we're going to project our heights across from the front view. And I've just got to go make sure I meet the same projections. Now 2 is going to be there, and 2 will stay there, fixed on that tilt there. Then I'm going to bring 1, 3, and just 1 and 3 across here. There's 1 over there. So if I project that across, there's 1. If I project that across, there's 3. Right? And then I'm going to project 4 across as well to intersect its line on 4. So I bring that across, there's 4 there. Right, so immediately you can see, if we were looking from the left-hand side of this object, we would see underneath the base. So we would see all the space under here. Okay? So you can go ahead and actually join those, but I'm just going to annotate them. That's 1, that was 4, and that was 3, and that's 2, and that stays there. Then we're going to project A across, the apex, the top, and there's A, so there's its projection line, and so A is over there. Okay, so we got the positionings of everything. Right, so if you get a slightly more complex object, this is a way to help you know what you see and what you don't see. Okay, so in the left view, we can see the tilt in relation to the base and the faces. From the left side view, you're definitely going to see underneath. You're going to see the whole base. You with me? Okay, now watch here. If I come to the top view and I stand from the left here, and I look at it from that point of view, I'm going to highlight a few things here. All right? You will notice that I'm going to see, and it's just quite a nice thing to do. If I look from the left, okay, I'm going to see 4. Do you agree? I can see that point. I'm also going to see what? The point of 1 and the point of 3. So that means I'm going to see all of that. Do you agree? Okay. I'm going to see then obviously the line from 1 to A. I'm going to see the line from 3 to A and 4 to A. Okay? The line from 2 to A, will I see it? No. So what I always say is, if I do this on my auxiliary, that's what I'll see. Okay, and I can actually go and join those lines up. And then everything around the corner of my auxiliary, I wouldn't see. Okay, so the first thing we can go do is join the base, the 4 base edges together, 4 to 3. Number 4 is the closest point to the eye. Is it? Oh, geez, that's not very neat. Sorry, very accurate, but Okay, let me try and straighten it up a little bit. Push it out. Okay. Yes, we're going to see 1 to A. We're going to see 4 to A. We're going to see A to 3. Right. So now, at the back, around the back, we're going to have 2, and 2 needs to go up to A. But we're not going to see it, so it's going to be hidden detail, 100%. Right. There it is. Okay. And that is your left side view in place. Now what you must do before you end here is make sure that your margins, your axis is something a little bit more visual. In other words, so I'm just going to make my axis a little bit darker. Just give me a sec here. And I'll try to line my axes up just to be on a little bit beyond the top and a little bit beyond the bottom. And now when we label this, the first one we did was X and Y. Remember that. X, Y is the first one we did. The next one we do is going to be X1 and Y1. Okay, so those are the only ones we need. X and Y, X1 and Y1. Right, and that's it, gents. That's a tilted solid.